using my Zoom. Okay, so I got to make sure everything is straight. Whoops, before we actually, go all the way live, because we're going to, okay, there we are. Okay, you guys can't see my face right now, of course, but I am going to share the screen so that everyone can see what we got going on. So let me go ahead and screen share my notes of where we left off yesterday. Okay. So, good afternoon, everybody. My name is Professor TK the Chemist, and I am a college chemistry professor. For those of you guys that are new to me, I do teach chemistry Monday through Thursday. Okay. However, when I go on TikTok live Monday through Thursday at 12 noon Eastern Standard Time, that is to give you guys the free tutoring sessions that you may need because your chemistry professor isn't giving you what you need, or you may be too intimidated or afraid to go and talk to your professor, but you can talk to me. I have an open door policy that I don't mind helping you guys as long as you guys are asking great questions and things that are related to what we're going through today. If you have other questions that you want to know the answers to as it relates to chemistry, hold on to like the last 10 to 15 minutes of my session, and then I'll go through what you need to know at that time. If it takes me more than 3 minutes to answer your question, I just ask that you put it on my last video so I can remember to do a video for you, okay? So I do take requests. If you need some help, you let me know. I have a lot of videos on my YouTube channel as well as TikTok. So if you guys have questions, please, 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 please let your professor know, okay? Now, also, when we're going through these problems, if there is something that you don't understand, please let me know, and I'll go back and rewind and do what you need to do in order to make sure that you guys got the problem, okay? Because I don't want anybody to be confused. We don't leave in confusion. We want to make sure that you guys are on the right track, okay? So, if you're ready, I'm ready. Let's get into it. The first thing you need to make sure is that you stay hydrated. Make sure you keep your water nearby. Next thing you want to do is have your pen and your paper and your notes and, of course, your calculator and the sense of wanting to learn. The reason why all of this is important is because that is how you get through chemistry, with a positive approach. Chemistry is not easy, but it's not hard. It is doable. You can do this, guys. You can do this. And what I don't want you all to do is to get discouraged, okay? I do not want you guys to get discouraged. So yesterday, we left on a problem that some of you guys had issues with. And I said, you know what? Let me just start that problem over so that you guys are able to see from top to bottom how this problem is supposed to go. So I did kind of somewhat get started on it. And as you guys can see here, for those of you all that are on TikTok and on YouTube, you guys can see the problem that I started off doing. I was trying to isolate the initial chemical reaction, the initial chemical formula of Gibbs Free Energy, which was delta G equals delta H minus T times delta S. And I was showing you guys how you can solve for delta G by isolating everything that you needed. But also in this problem here, we also were trying to find the temperature though, okay? The temperature was also being required. And I know a lot of times when you're trying to find certain things, you got to learn to work backwards. And if you don't know how to work backwards, you will have trouble solving these problems, okay? Chemistry, it does require you to learn how to manipulate equations to solve for your unknown. So if you're not able to do that, you will have trouble, okay? So, well, I'm going to show you, let's see, yak to go. I'm going to show you how to do that. So I know all this on the screen looks a little like, what in the world? But I'm going to go ahead and show you guys from top to bottom how to do this, okay? So I have to type out my notes to make it easier. And I also started doing pre-work because a lot of times I run out of time when I'm doing these problems online because they take so much work to do. So I like to do this, okay? Okay. I miss Gia online. Hey. Thank you so much. I appreciate you. You said now MCAT coming up. I know chemistry about to take me out. Well, no, chemistry doesn't have to take you out. As long as you hang out with me Monday through Thursday, I got you. Hang out with me Monday through Thursday. What did you get your bachelor's in? Was it in chemistry also? I Miss Gio online. So what? Oh, you go. You go ahead. Mechanical engineering. Okay. Maria Butterfly, what you can do is if you want to find practice problems like this, you can do the ones that I have, and you can just pause the video and see if you can work it out yourself. So if you want to hang out with me, you can actually do these types of problems with me and then, pause the screen before you see the solution. Yes. Now, and then you can also Google, just key in the words thermodynamic word problems for chemistry or Gibbs Free Energy word problems. Okay. Thank you. Okay. All right. So let's go ahead and get into this problem here. And also, too, sometimes I'll show you all the answer off to the side. I have tons of workbooks that I actually use when I'm giving you all these types of practice problems. When you've been teaching for as long as I have, which is 27 years, you will end up with a buttload full of books, a library full of books. Okay. My bookcase is full of chemistry books. So I have a wealth of problems that I actually pull from. Okay. So what I like to do is show you all the easy way, but I also like to show you guys the challenges that some of your professors will show you or take you through when you're doing problems such as this. So let me go ahead and zoom in a little bit so you guys can see the problem a little bit better, okay? And I'm going to explain to you all how this problem works. You're not really interested in the answer anyway, because I'm going to show you how to do the answer. But for this problem, it says for the vaporization reaction, bromide liquid goes into bromide gas. They give you the delta H, delta S. They do not give you delta G. However, they're wanting you to find the temperature. Now, one thing I need to keep you all, let you all be aware of the fact is that the temperature in this formula here, you can actually isolate this, okay, this formula for delta G. Okay, you can actually solve for temperature. Now, here's something else I want to kind of show you too. That delta G, when we look this up on our chart for this particular chemical reaction here that I'm highlighting, the delta G was actually equal to 0. Okay, so let me kind of put that here too. It was equal to 0. And because it's equal to 0, if you take that formula, delta G equals delta H minus T times delta S, and you know that delta G was equal to 0, okay, then it's almost like you're able to just pretty much say that T is equal to delta H divided by delta S, okay? That is essentially the formula for finding your temperature, all right? Now, what they gave you was the delta H, which was 31.0 kilojoules per mole. They also gave you delta S, which was 93.0 joules per mole Kelvin. Now, what you got to understand is that in this problem, because they gave you joules, you cannot work with kilojoules and joules in the same breath. So therefore, you're going to have to do what? Convert, okay? So this is where this problem solving here comes into place, right here. You're going to have to convert. So how do we convert that? Well, we've got to take the 93.0 joules and divide it by 1,000 joules to get my kilojoules, okay? Oh, good job, Celestial. Well, I did too. That's why I became a chemist. So when you divide 93.0 divided by 1,000, you're left with the kilojoules. And that was equal to 0.093 kilojoules. Remember, the formula is delta G is equal to delta H over delta S, okay? But because this delta G was actually 0, okay, I'm going to actually replace that delta G that you see in the formula with a T for temperature, because that's what we were looking for. Because remember, delta G, when we went to our chart, delta G was equal to 0 for that particular part of the reaction. So therefore, you're left with T being isolated, and you're having to solve for that. So you end up with delta H over delta S. My delta H that was given was 31.0 kilojoules per mole. And the delta S was, when we converted it from joules to kilojoules, we got 0.093 kilojoules per mole Kelvin. Of course, when you cancel out your kilojoules and your moles, you're left with a Kelvin as your final answer. So I left this part here because I wanted to show you all the answer in terms of like when I plug it into the calculator, okay? So right here, you end up with 31 divided by 0.093, and you get 333 Kelvin. So that is my answer. Now, the question also wants to know, if I go back up here, at what temperature will this process be spontaneous? And the answer, as you guys can see, is above 333 Kelvin. Now, Yakgo said, can you explain how to get T alone like that? Okay, I'm going to go ahead and show you again. So we did this yesterday, but I don't mind showing you as well, okay? So I'm going to show you here. Matter of fact, let me go ahead and erase this so you all don't see that part. Okay, remember the formula is delta G equals delta H minus T times delta S. Now, if this is my formula and I'm asking you guys to look for T, first thing you need to do is do one part of the equation at a time. Delta H right here is positive. So I'm going to subtract delta H from both sides. And as you can see, this cancels out, okay? And so you're left with delta G minus delta H okay? Not yet, Shohak. Thank you so much for joining. We'll get back into that too. And then that's equal to negative T times delta S, okay? Now, remember, if I'm trying to look for my temperature, I'm going to divide both sides by negative delta S. Negative delta S. I'm dividing both sides by that. And again, the delta S's are going to get canceled out, okay? And so now you're left with a positive, okay? So you can see this. You're left with a positive T. Because remember, I divided it by that negative sign right here, by the negative delta S on the other side. Now, that's equal to delta G minus delta H over negative delta S. Now remember, delta G in this problem was set to 0. And because this was set to 0, that means you have left over negative delta H divided by negative delta S. And remember, the negatives go away. So therefore, your T is equal to delta H divided by delta S, okay? I hope that makes sense for you. Did you understand? Okay, and you weren't being slow. Sometimes it doesn't click, and it's okay. Just go back over it again. Sometimes I've had to do problems 3 and 4 times in order to get that aha moment, and it's okay. The point is you get it when you can, and then hold on to it. Okay? Now, what I'm going to do, okay, wait, can you explain what happened to delta G? Okay, Omari or Omarie. Yeah, thank you, Yakgo, thank you. It was set to 0. And because it was set to 0, it went away. So you're left with delta H divided by delta S. And the negatives cancel out. I will be doing electrochemistry. Iconic. How you doing today? I know you were here with me yesterday and you were inquiring about electrochemistry. I will do electrochemistry on next week. Okay, simply because since we're in this unit here that deals with activation energy, because that's coming up next also, I will start on that electrochemistry as well. But give me a problem that you may need me to do, and I can help you on that specifically. When is your test on electrochemistry? Yes, that's right. Yes, this is still thermochemistry. Yes, iconic. This is still thermochemistry. So yes, you didn't miss it. Okay. So now I'm going to show you all some other examples that will further clarify this, okay? So the thing you have to remember is that you have to read the problems to make sure if they've left things out or if they've converted them, or let's say they gave you, like I said before in this problem, they gave you kilojoules and then they gave you joules. You've got to make sure that both of those units are the same. Okay, so you got to convert your joules to kilojoules, and just remember to divide by 1,000 to get that. Yes, Moose Man K1, my YouTube channel is Learn Chemistry with Professor TK the Chemist. Learn Chemistry with Professor TK the Chemist. And I'm actually live over there right now doing this same lesson here on YouTube as well. Because so many of you guys requested that you get the problems, and I could never get them from TikTok. And so I would have to wait too long to download the video. So I'm just simply going live on YouTube at the same time as I am doing it here. Christian Hill, let's see, can I do something on intermolecular forces? Yes, remind me of that. Put that on my last video so that way I will remember to do it, okay? Because that's something different than what we're doing today. Now, here's the other thing too, okay? With these problems, you've got to look at everything and make sure that units can cancel out. Make sure that your temperature is in Kelvin. If your temperature is not in Kelvin, guess what? You've got to convert it by adding 273 to the degrees Celsius. Yes, Rando. So look, because you had a quiz, you know what's going to happen? You're going to have a test also. So no love is lost. Come back, hang out with me to get those thermal questions answered for your test coming up. Again, my YouTube channel is Learn Chemistry with Professor TK the Chemist. And the link is in my bio, so it'll take you straight over there. Make sure you follow and don't forget. Okay, so I'm going to actually show you guys another set of problems, okay, that you all will have to learn in order to do these thermodynamic problems. Something else you guys need to know, and I wanted to kind of pinpoint this out to you guys. We showed a chart like this yesterday. If your delta H is negative and your delta S is positive, your delta G will be negative, and that's a spontaneous reaction. If your delta H is negative and your delta S is also negative, your delta G will also be spontaneous, but at a lower temperature. However, if your delta H is positive and your delta S is positive, then it will be positive, but your delta G will be positive and not spontaneous. And even though it says negative at higher temperatures, you still want to consider this also. So I would write both of them down, because that's going to come up in a problem that we're going to do in a second. If your delta H is positive and your delta S is negative, then your delta G will be set to 0, which is pretty much what I was showing you guys before. And how do you know negative versus positive is exothermic versus endothermic? Remember, exothermic is releasing energy. That's why you have a delta H being negative. Positive is endothermic. That means you are absorbing temperatures, okay? So let me show you guys Oh, yeah, here we go. Yeah, this is the problem sets that I wanted to go over with you all. And again, I always pre-do some of this because I know a lot of times I run out of time. I'm just going to be honest. I run out of time, and it's because I'm writing everything out. The Georgie Figs show. I feel you. I understand. Now, since we're still on entropy and free energy, I want to kind of go over some practice problems where you're having to use delta G as your formula. So this somehow got erased. Okay, so here you've got a problem where they want you to compute delta G based on the information here and to predict whether the reaction will occur spontaneously. So here's the deal. You know that the formula for delta G is equal to delta H minus T times delta S. What I want you guys to understand is that the delta H is positive, delta S is also positive. We've got to figure out what the G is in order to know if this particular part is going to appear as spontaneous. How do we figure that out? Let's plug the numbers in. Now, I've done some of the work already, okay? So I've done some of the pre-work so that we can do the calculations part together, okay? So right here, they told you delta H was 125 kilojoules, okay? The delta H was 125 kilojoules per mole. The temperature was 293, okay? And the delta S was 0.0350 kilojoules per mole Kelvin. So we're going to calculate delta G to find out if this reaction is positive or negative, which will determine the spontaneity of this. So first thing we're going to do, we're going to cancel out the K's for Kelvin because we don't need those. Okay, they're the same on the top and the bottom. But what you're left with is kilojoules per mole. So I'm going to go ahead and plug in 293 times 0.0350. And I get, let me make sure that's right, 293 times 0.0350. And I get 10.3. Okay, so right here, as I write my information down, I'm gonna write it in red so you all can see that this is the answer right here. Delta G is equal to 125 kilojoules per mole minus 10.3, okay, kilojoules per mole. So what we need to do is subtract those two numbers, okay? So 125 minus 10.3 gives me 115 kilojoules per mole. Now, because that is my answer, okay? Yes, Shohak, I will save that part towards the end, okay? Yeah, I'll save that question towards the end. So because I get a positive 115, okay? Positive 115 right here. What can we say about this particular reaction here? The answer here is this is non-spontaneous, okay? This one is non-spontaneous. So I'm going to write that over here so you all can see that, okay? This is non-spontaneous. And I know, hold on, that's a little sloppy. I don't like the way I wrote that. I'm going to write it here. And I'm going to highlight it so you all can see, okay? So we just answered this question. Because our answer is 115, because it is positive 115, okay? This is spontaneous. I'm sorry, this is not spontaneous. If it were negative, it would be, but because it is positive, it is not spontaneous, okay? Not spontaneous. So think of it this way. Spontaneous means, like if you were spontaneous, that means you were like a surprise. or you were trying to be you were trying to change the mood, trying to change the setting. If your spontaneous situation is positive, okay, then there's nothing spontaneous about that. But if it's negative, then it is. Okay, sometimes when you try to flip the script, it could turn out to be a negative situation when it's spontaneous. Sometimes you got to come up with mnemonics to help you remember these things. Okay, so if it was negative, would it be spontaneous at high temperatures or all temperatures? Okay, so yeah, let's talk about that. Okay, so again, if we go back to our chart, okay, because these are great questions. Here's the chart once again, so you all can see it. Okay, and you were asking about spontaneity. Hold on, it's on my other one. Hold on, y'all. Right here, I think I put it at the very bottom. Yes, so right here again, it depends on the temperature, yes. JJ and Shohad, yes, it depends on the temperature, okay? And also the delta G. The calculation that we got was positive, okay? So that's why it was not spontaneous. And remember, the delta H was positive. The delta S was also positive, and the calculated value for delta G provided us a positive factor, so therefore it is not spontaneous. And yes, to answer your question, this would be endothermic. This is an endothermic reaction. Endothermic reaction. Okay, let's go to the next one. Okay, let's go to the next problem. And if you want to, if you want to put that down too, you can put endothermic as well. Okay. Now, in this next part of our problem, this is part B, okay? Part B. So here's what they gave us again. They gave us the delta H is equal to negative 85.2 kilojoules per mole. The temperature was 127 degrees Celsius. Remember what I said, temperature must be in Kelvin, so we add 273 to that number and we get 400 Kelvin. Our delta S was 0.125 kilojoules per mole Kelvin. So again, the delta H is negative, the delta S is positive. Now you do have a very high temperature. So let's take a guess, guys. Is this going to be a positive or negative delta G? Y'all tell me, a negative or positive delta G before I show you the solution. And also remember, this is a high temperature. So is this going to be spontaneous or not? Okay, Shohak said negative. Okay. So if it is, okay, so let me show y'all. Let's put this here in the chat. If it's negative, if the delta G is negative, then that's spontaneous. Okay. Of course, it depends on the temperature. And let me put that depending on the temperature. Okay. If the delta G is positive, if it is positive, okay, then it's not spontaneous. And again, it depends on the temperature for those little variables, okay? So far we know, in this case, delta H is negative, delta S is positive. What do y'all think the delta G is going to be, negative or positive? Spontaneous or not? So far I see several of you guys are saying spontaneous. Okay, let's solve the problem to see if you're correct. So right here, remember, we went on ahead and calculated our temperature to be 400 Kelvin. That's why it's down here, it's 400. And we're going to multiply that times 0.125. Okay, so I have not done this part yet. Okay, I'm going to actually do this with you guys. So we're going to do this together to find the answer. So 400 times 0.125 gives us 50. So negative 85.2 kilojoules per mole minus 50 kilojoules per mole gives us what? Let's see what the answer is. So 85.2, okay, negative 85.2 minus 50 gives us negative 135.2 kilojoules per mole. So if we look at our number here, we have a negative delta G. Negative delta G. Because it is a negative delta G, this is spontaneous. So for those of you all that said spontaneous in the answer, in the chat box below, you are correct. So because it is negative, I'm going to highlight this answer here in the box. It says this is spontaneous. Okay, this is spontaneous. All right, Dr. Snail. I got you. Okay. Remember, to be spontaneous, you have to have a negative G. Okay, to be spontaneous, you have to have a negative G. All right, you know we got another one, right? Because sometimes, it takes more than 2 examples to make it click. Wow, Shohog. Okay. Let's look at the values here in this next problem. We've got a negative 275 kilojoules, okay, per mole. So we have a negative delta H. The temperature is pretty high. The temperature is 773 Kelvin. The delta S is positive. Is positive. That's right, Dr. Snell. Just power through it. They got this. You are absolutely right. What do you guys think the delta G is going to be? Positive or negative? And spontaneous or not? So put your answers in the chat box below. Let's predict what you guys think is going to be. Put your answers in the chat box below. Yes. Okay. So, okay, JJ said negative. Okay. What else? What else? What else? Who else agrees with JJ? Y'all think it's going to be negative or positive? Spontaneous or not? Okay, let's solve this problem. Okay, Showhawk says spontaneous. Let's see. Fire says spontaneous. Okay, so again, you guys know I've pre-worked some of these steps in terms of just plugging the numbers in. So we've got negative 275 kilojoules per mole minus 773 times 0.450. So again, I'm going to go on my computer on the screen and put 773 times 0.450. Okay, so it gives us 425. So right here, I've got negative 275 kilojoules per mole minus 425 kilojoules per mole. Because remember, your kelvins canceled out and you're left with kilojoules per mole. So 275, okay, negative 275 minus 425 gives us negative 700. The answer is negative 700 kilojoules per mole. And because we have a negative sign, again, you guys know that this is spontaneous, okay? So it's negative. So therefore, it is spontaneous. Negative 700 kilojoules, per mole. Sorry, you guys couldn't see that answer. Negative 700 kilojoules per mole. Now, as we switch up the gears a little bit, okay, Any questions on this before I go to a different problem along the same lines of what we're talking about? The nostalgia, okay? Let me see if I can check on my other folks over here on YouTube. Let's see. I don't know if I'm gonna be able to, but let's see. We're talking about. Okay, I'm gonna mute this. All right, there we go. So everybody's good so far over here. Okay, so far so good. Okay, so I'm gonna go back to the problems we were doing. Okay, now on this next example that I've got, okay, right here, it says the delta S for the reaction shown at 298.15 Kelvin is 0.00300 kilojoules per mole Kelvin. Calculate the delta G for this reaction and determine whether it will occur spontaneously at 298.15 Kelvin. And they gave you, okay, so in case you didn't know, this right here would be classified as the delta G, okay? I'm sorry, well, the delta H, sorry, delta H. This right here is the delta H, the 393.51 delta H. Now, what you're going to do is, again, plug and chug, okay? Plug and chug. We do know that the delta S, and I did not put this off to the side, but I'm going to do it for you guys. We do know that the delta S is positive. The delta H is also positive. And the delta H was from this reaction here, okay, that they're giving you, that I'm highlighting. That is your delta H value. That's positive. We're trying to calculate the delta G. So far, we've got two positives. Let's see what will happen here, okay? Well, I hope, Raquel, that you passed your test today on this information. So what we need to do is plug in that 298.15 times 0.00300, and we get 0.894, okay? So we only needed 3 of those numbers. So my delta G is equal to that 393.51 kilojoules per mole minus 0.894 kilojoules per mole. We already know we're going to have a positive value here. Okay, we already know it's going to be positive. And because the answer is going to be positive, that means this is not spontaneous. But let's see what the answer is. 393.51 minus 0.894 gives us 393. Positive 393 kilojoules per mole. Therefore, this is not spontaneous. Okay. Let me put this here. Not spontaneous. Not spontaneous because of that positive number. Okay? When it's positive, it is not spontaneous. You said you graduated last fall. Why does chemistry keep popping up on FYI? Chemistry killed you. Honey, it's trying to call you back. Okay, Essence? It's calling you back. You know you miss it. Okay. I got a few more minutes before I have to log off, but let's do one more example, okay? And this one deals with, oh, thank you, Radon. I think, yeah. Oh, do you have to take General Chem too? Well, you took General Chem, so I'm assuming you took 1 and 2 last year. Okay, so now my chemist on here, y'all hanging with me, and I appreciate that. we got this last problem, and you all know, because it involves so many steps, I pre-worked them out. Okay, fantastic, right on, fantastic. So I pre-worked out some of this stuff because, y'all, look, if I didn't pre-work some of these problems, we would have still been on the first one because of all the writing that's involved with thermochemistry. Y'all, you know it takes you a whole sheet of notebook paper, okay? So in this problem, oh, you're welcome, JJ. Whatever questions you have, let me know. When is your AP exam? I know most AP finals are in May here in North Carolina. But if you need like a powwow study session, I can help you. So I'm going to do this last problem with you guys, and then y'all know I got to head out because I've got some more things to get going with chemistry. So right here, yes, that's right. It is the first, okay, the first week of May for your set as well. Okay, yes. So if you need me, you know how to find me, okay? In this problem here for delta H, if they want you to calculate the delta H for this reaction, this right here is what your problem should look like, okay? It should look like this once you flipped it and reversed it, okay? So no, well, yes, show how, yes, somewhat like that. Products minus reactants, yes. But I'm gonna show you exactly how to address your question. Since I highlighted what the reaction should look like, okay? Hold on, guys, let me get a sip of my water. Since your reaction should look like what I highlighted in yellow, calcium oxide plus sulfur trioxide produces calcium sulfate, you're going to have to rearrange some of these reactions here. If you rearrange the reaction, that means your sign is also going to change for your delta H. So if I look at the fact that SO3 in this reaction that I highlighted in yellow is also on the reactant side, okay? I look at H2O plus SO3 gives H2SO4. Guess what? This one can stay as is. I don't have to change this one, the one that I'm highlighting. Look at the next reaction. H2SO4 plus Ca produces CaSO4 plus H2. Well, guess what? CaSO4 is on the right side in the original part of the equation. So guess what? I can keep this formula or this reaction as is as well. Calcium in the third reaction, calcium plus oxygen produces calcium oxide. Well, guess what? Calcium oxide is on the right side, but in my original reaction here at the top that I'm putting a purple star by, it's written first on the reactant side. So because it's on the reactant side, I'm going to have to flip this third reaction. So let me highlight that one for you so you will know. That one must be flipped. And because you have to flip the third reaction, that means your sign for delta H must also change to a positive. Let's look at the last one. H2 plus O2 produces H2O. Well, this one is fine because we're going to have to cancel it out. So we don't have to flip that one. So I'm going to highlight that in yellow. Now, because everything that's in yellow is okay, I rewrote those three equations. The one that I flipped was the one written in blue. And because I flipped it, calcium oxide now is on the left side because that's how it appears in the original formula here, okay? From above in yellow. Now, what am I going to do next? I'm going to start canceling out things I do not need. Okay, I'm going to cancel out things I do not need. And yes, I wrote the numbers down that were beside it. The only one that changed was the 634. That became positive. Okay, so because I want my original reaction to look like this right here with the calcium oxide plus the SO3 producing CaSO4, Let's see how we're going to get to that point. So what am I going to have to do? I'm going to have to start slashing out things that we do not need anymore. H2O cancels out with H2O here. You see how I cancel both of those out? One is on the left, one is on the right, cancel. You need SO3, so we don't have to cancel that out. SO4 is on the right, SO4 is on the left over here, so I cancel those two out. Ca is on the left, Ca is on the right here, so I cancel those out. And finally, H2 is on the right, H2 is on the left, you cancel those out. And the oxygens, you cancel both of those out. So what do you have left over? You have SO3, and I'm putting that in yellow. You have CaSO4, I'm highlighting that in yellow. And you also have CaO. Okay, I'm also highlighting that one. And so what I highlighted in yellow is what I wrote down here, okay, in this yellow box. So you guys can see that. So now I'm going to have to pull these numbers down, guys. I'm going to pull those numbers down and start getting my answer. I've got negative 132.5 kilojoules per mole minus 602.5 kilojoules per mole plus 634.9 kilojoules per mole minus 285.8 kilojoules per mole. All of that gives me negative 385.9 kilojoules per mole. Is this spontaneous or not? This would be spontaneous. Thank you guys so much for those hearts and those badges and those roses. I appreciate you guys. This is spontaneous. Now, Shohak said, if there was a stoichiometry involved, would you multiply H by the coefficient? Yes, so we did that yesterday. So if you have a coefficient where, let's say you had to make calcium oxide, let's say you had to make calcium 2, you had to put a 2 right here in front of it, then everything would be multiplied by the 2, including your delta H value. So yes, what you do to one part of the equation must be done to the other part. Let me see if I can find that one for you. And this was the last problem, guys. So we actually finished. We actually finished all the problems that I set out for you all to do. But let me show how the question from yesterday that we actually did, because that was a very good question. Let me see if I can find it. Yeah, this was the one right here. Okay, yes, JJ. I go live Monday through Thursday, 12 noon Eastern Standard Time. 12 noon Eastern Standard Time, Monday through Thursday. And I will be going live in the evening time beginning next week, beginning in April. I will be going live in the evenings also, in addition to the daytime during the day, Monday through Thursday, 12 noon Eastern Standard Time. And you guys can find me also on YouTube at Learn Chemistry with Professor TK the Chemist. Yes, Ava, I will be live tomorrow at 12 noon. Same time, same place. Yes. Show how, so this question right here that we did, the reaction that we needed. Let me zoom in a little so you can see that. Okay, you see this 5 right here, that 5 carbons plus 6 hydrogens produces C5H12. That's what we wanted, right? But guess what? We were given just regular carbon. So we had to actually multiply that entire reaction by 5 in order to solve this problem. And I went in detail with that particular reaction. And I also had to multiply that times the delta H as well. So yes, if you have coefficients that you multiply, you have to go all the way across to every part of the problem. Yes, that is correct. Thank you, Adeo. Thank you so much. I appreciate you guys for hopping on. Thank you, Lil, for the follow. And ZS, thank you guys so much for following Professor TK the Chemist. If you all need help please don't hesitate to hit the link in my bio. I got you, got you, got you. Okay. And yes, Shohag, I will most definitely do that for you. I'm going to write this down right now to make a note for this to go over the phase changes. Okay. So also, can you go over S and how it relates to phase change? Yes, I'm going to do that for you tomorrow. Okay. And I'm writing this down. But matter of fact, I'm just going to screenshot it so I don't forget. Okay. And I appreciate you, Shohag, also for hopping on. You've been with me for a minute too. And I appreciate that as well. So you guys have a wonderful, wonderful rest of your day. And remember, don't let anyone lower your aura just because they aren't where they need to be. Some people can get you off track, but don't let them do it. Don't fall for the okie doke. You keep pushing. If people say, oh, you don't have to study today, take a break. Nope, you stay with it. The semester is coming to an end soon and very soon, and you do not want to get behind because you want to go partying and playing, okay? You don't need to get too comfortable. At the end of the semester, that is not the time to relax. You got to keep pushing. Don't stop, get it, get it. Okay? So you guys have a wonderful afternoon. I'll see you tomorrow.